Good morning, gentlemen.
Good morning, sir.
Good morning, sir.
How was your night? Was it good?
That was
Very
fine. It was good with a lot of good dreams.
I believe that you guys received. I sent as soon as we finished. I sent you guys the slides. You know what I'm saying? So I believe you guys went over them. This course like this, you have to be on top of it. As soon as we finish lectures, you go over wherever you did. You finish lectures, you go over because I know you guys are workers. So only one person who is not working now. So if you are not careful, you won't get time to study that much. You understand? So as soon as you finish lectures, just jump over it. Go over it. Then every time it will be on your mind. You understand? Every time the studies will be on your mind until you finish, and then soon you reach level 400 and then you'll be able to finish quickly. You understand? Okay. So today, you understand? I don't know whether we have received a new person or not. But if you're a new person, then let me introduce myself to you. My name is Dr. Ben Asante, engineer Dr. Ben Asante. My engineering with the IET, Institution of Engineering and Technology. That's a Ghana GH. Right? So without much ado, this is my mobile lines. If you're a new person, those who are here with me yesterday, I give them my mobile lines. All right, 0200773728, and then also the Tigo line, Airtel Tigo 0277383722. I also have an MTN line. All right, MTN line, which is 05958 05958444137. That's also my MTN line. All right. I haven't listed it here, but in course of time, I'll put it there. All right. So let's go over those are my email addresses, Asante at gctu.edu.gh, and my private one is asanteb683 at gmail.com. All right. So in this case, right, like I said yesterday, I'm always closer to my um WhatsApp lines. These my two WhatsApp numbers are on WhatsApp. The mobile, the Voda, and then the Telesa, the Telesa, and then the Tigo. They are on WhatsApp. All right, so you can WhatsApp on them. But my preferred WhatsApp line is the 02007773. All right. So both of them they are WhatsApp, but this one is my preferred one. All right. So let's go over the course outline and then see what we have to do. You guys are not on campus, so like if you want to get in touch with me, just contact me through my WhatsApp line or my email address. All right. Um, because you guys are not chemistry students, all right? You are electrical and electronic engineering students. So this course has been carved primarily for you guys the way it has been done. Because if you are chemistry students, then we'll go to different dimensions, different angles. But here we have carved it, primarily for you guys. The module book is there. The module book is there. So I expect you to go over the model book. Uh, 1 minute. Hello, W, W, W. Yeah. So the objective of this course, right, is to introduce to you guys the basic concepts, right, of chemistry and how you can apply them in your field of work. All right. Apply it in your field of work. Right. Let me go down the objectives of the course. So the course requires you, the student, to have knowledge in mathematics, of which I know, all of you, because you're engineering students. So I believe that, you have knowledge in mathematics, and also, just such as algebra. You know, you're not going to be doing a whole lot of, things like integrations and differentiations and stuff like that. And you also have to have a knowledge in English language. Right? You don't really necessarily have to have a physics background. You don't have to. So chemistry is a course on its own. Even though it's a physical science, it's a course on its own, right? All we have to know is to have to know some algebra and some, English, so that when you can really interact or read whatever material which is been assigned to you. And this is the thing, because this course is you guys are distant learning students. Most of our interaction will be on online, how we are having today. And at some point in time that you come to the campus to meet me face to face. All right. I'll give you homework. All right. And if you look at your model book, there are homeworks on it. So after lectures, you do the homework. You submit the homework, and then you get a grade for it. All right. These are the materials you can read. All right. The um besides the module book that are prepared for you. All right. You can also, if you find these books to read, that'll be fine. Next time I'll try to see if I can connect this guy who's a Pearson guy. He's also, they come to the campus, they're on our campus, and they also have other materials that they can also give to you at a cost. You understand? And it's not too much, though. The cost is not too much. You can access those books for I think 6 months or so. You pay approximately about 100 cities for that. You understand? So he also has those books for you. So these books, you can access them. Thomas R. Gilbert, as a chemistry book, you can have Raymond Chan and Kenneth God's B. It's a general chemistry book. Martin Selberg, general chemistry book. Ralph H. Petrucci, also general chemistry book. All right. Sometimes some authors will explain it differently the way that you understand it better. That's why we recommend different type of books for you for the same course, so that if you read it, you don't understand. Be like, you know what? Let me go to this book and read this book, and then that book can really, reinforce your understanding of it. All right, on that particular subject matter. All right. The grading criteria is the same thing like the environmental studies. All right. This semester is exams is 30% plus assignment and attendance. And I see whoever came here. I'll record attendance. That is also 10%. And the end of the semester exams is 60%. All right. So the topic by topic for week by week, I have put them in the topics and then schedule. Week by week, we'll be studying all these. Week by week, we'll be studying this. The times that we will have to also do the semester exams is there. All right. And then from there on, we'll come all the way down. Then we'll do our end of semester exams. The semester will be over. All right. Then you go to the second semester for all your level. Okay. So any question on this course online before I move on? All right. So if there's no other question, all right, then I can just unshare this document, and then I'll share another document. Can you see the screen?
Yes, sir.
Listen,
Yes,
bro.
sir, we can.
Good. Um, Let me introduce you to general chemistry. All right. You have different type of chemistry. You have applied chemistry, and general chemistry. You have organic chemistry. Uh, Different type of chemistry. Yes, and depending on what your field of study and what you really want a chemistry to do, you understand. So, but all in all, chemistry, right, is the study of matter, and then the changes that matter undergoes. All right, the changes that matter undergoes. That's more of chemistry. We study things that are around us, you know, matter, things that are around us that has mass and occupies space. It has mass and it occupies space. All right.
Like
And then we see the changes. We study the changes that the matter will undergo, right? And then chemists, they use substances that make up matter to identify them. Substances that make up the matter to identify them. Substances that make up matter have unique properties. All right. So that's the reason why when you take gold, you take diamond. Why is it that they are not the same? Why is it that gold when it's shining and then diamond has that kind of a silverish silver kind of color? Why is it that charcoal is dark black? Why? There's something inside, right? There's something inside that makes that changes. All right. So chemists they take those things and then they study the properties of them. You see that, oh, okay, this is the reason why gold behaves this way. That's the reason why diamond behaves this way. This is why this material is so brittle. This is why it's so ductile. This is the reason why this material is so ductile. This is the reason why this material is so hard. And this is the reason why this material is so soft. This is the reason why this material it had this color and this material had that color issue. So there's some certain inside the way the things are. So that's what the chemists are doing. They are all concerned with developing tools. They develop tools to study matter and then the concept to describe the properties of matter, right? They try to change the forms of matter into new materials. You understand? Otherwise, we wouldn't have all this laptop that I'm talking using. You too, you won't have those, your fancy phones and your cars and this and that. A whole lot of materials that we are using in your car. Look at all the materials in your car. You have this, Bluetooth in your car. You have a leather in your car, metals in your car. So a whole lot of stuff in your car. You imagine, look at your car. So chemists, that's what they do. They change, forms of matter, that God has given to us, and then they put it in such a way, change of certain things in such a way so that we can have different material out of what God has given to you in the natural way. Yes, and that's the reason why you guys are in school now. You are studying. That is science, engineering. You are studying all these things so that you can change different forms of matter, to give you different things. So that our life will be comfortable. All what we are doing, we are studying and this and that. It's not like we just want to bombard our brains with different kind of things that we don't understand and then we are fighting so hard. No. We are doing all these things to help me and you, to help us to be able to change things to make our life comfortable. To make our life comfortable. Huh? So wherever you are, whether you are in your office or in your house, if you have your AC sitting down your AC because it's hot outside, it's hot, and you sit in your comfortable chair, you sit, your life will be comfortable. So that's what chemists are doing, right? They try to change different forms of material into other forms. All right. Hmm. They observe matter and changes and goes using microscopic amount of material. They take big material of it and then they try to see how it will change to a different form, all right? And then they interpret the properties and changes in matter in terms of atoms and molecules, right? So the fundamental concept of every material, right? Materials, they go all the way down to the minutest part of it, the smallest part of it, and then they try to change it, look at it, how it behaves, and then they know when they change that smallest part of it, they can change the whole of it. You understand? And the atom, as we defined it yesterday in the environmental studies class, the smallest particle of an element, right? So if you take matter, which element which is a matter, and then you try to go all the way down, take the smallest part of it, smallest part of it, which is called the atoms, and then you manipulate it. You can change that material, and then once you can change that material, then it can give you different things. You get it, you manipulate it, you arrange it, or combine it and do different things to it, then it can have different forms, all right, of matter. Do you get it? Even some of the drinks that you drink, they say, oh, it's orange drink, or it's an apple drink. This one is guava drink. This one is, pineapple drink or whatever. All these things, you think they are real pineapple that they really, cut the pineapple and then dry it and make it drink. No, it's some kind of other form of, maybe matter, and then they manipulated it to make it taste like, I don't know, like apple. But it's not apple. Some of the smell, you have a perfume, you smell. I remember in the US, I used to go to a place to buy in New York. They call it nature's element. They have different forms of perfumes, and then some of them will smell like orange. If you want to smell like orange, very nice smell. If you want to smell like coconut, very nice coconut. And all is about manipulating those atoms and molecules to make it smell like coconut. But it's not actually naturality. It's not coconut. You get it? Now, don't get me wrong though. There's some juice. They say this is coconut juice, pure coconut juice, or pure orange juice, or pure pineapple juice. That one is pure. And yeah, there's no any manipulation whatsoever. There's a pure of them. But believe me or not, there's also some form of matter that they can really manipulate, those atoms and molecules to give you different forms of matter. All right. So chemists use scientific method to guide their search for new knowledge. Right. Otherwise, it will be here and there, to be helter skelter. So scientists, they use some kind of method to follow whatever they do so that they can really replicate whatever they do from now and then. All right. They use scientific method to deduce facts about the microscopic world of atoms and molecules from macroscopic observation of reactions and properties. All right. So they go down, see the reactions that go on. They're using the atoms and molecules. All right. Then it can change the bigger part, the bigger picture of it, to give us what we are looking for, or to give them what they are looking for, to help the world, to make our life comfortable, to make us feel good in the world that we live in. All right. So we are really studying chemistry to see that, oh, okay, this material that we, the electrical electronics engineer, we are using copper, we are using this, Intel, we are using chips on, the chip that we're using in our phones, the chip that we are using in our laptops, the things that we are using, okay, it come from matter, and it come from chemistry is part of it. We appreciate what you are doing. All right. So when they are using this, they are using some method to guide their search for new knowledge, all right, the new materials, observation, and experiment. And then they also form hypotheses, they formulate hypotheses, and then they formulate laws, they develop laws, and then they form theories. All right. So these are the four stages of scientific method that chemists they use to get the new knowledge, to acquire new knowledge. All right. An observation and experiment, right? They define the problem clearly. The problem they're going to solve, they will define it clearly. And then the defining clearly is to find a systematic, logical approach towards a possible solution. Okay, now we are looking for a material whereby when we go to space, we go to and we are coming down. When we are doing the re-entry, we'll not catch fire. So then let's find the material. How are we going to, which material are we going to use so that its heat capacity will be so low that it will not catch fire? Because if the heat capacity is very low, then it cannot catch fire. because heat is CP delta T, CP delta T, so that okay, if the CP is very low, then there will be no of that material. So then how will we find it? How are we going to develop it? We are going to get an aircraft to move from here, all this space, speed from Ghana to US or to UK. Which material are we going to use so that when this car is going to so this plane is going so fast, the materials will not disintegrate. This one will move from here, this one will move here, and then you'll be in the sky all by yourself. You see, this is the science that we are. So we observe the problem. We observe the problem. We define them clearly that this is what we are going to solve. You understand? Then we'll find a systematic, logical approach towards the solution. Okay, we're going to find a possible solution towards it. Right? The approach to take to find what it's looking for is what I'm talking about. And observation, measurement at time. They do experiment, right? We do experiment. And then when you're doing experiment, we observe and we measure. We do measurements. And then we write it down, right? That's what scientists do. They write it down. And when you're doing it, write it down, right? All your observation experiment, write it down. Right? You collect information about whatever you're doing, then you write them down, right? You collect data, you write them down. Okay, use this. You do prototyping. So then let's do this and write it, and then see if you can get the material that we are looking for, right? You write those things down. Then when you have, written all those things down, the data, then you try to make a statement. All right. I'll give you a minute for you to talk. Can you hear me anyway? Maybe. Can you hear me?
Yes, sir. Yes, sir.
Okay. I'm hearing the feedback from whatever, I'm talking now. So, but can you hear me well? Does it give you a feedback?
No, sir. No, sir.
Oh, okay. Because there's some few time that somebody tried to score. I was getting the feedback. All right. So if it's okay, then let's keep going. All right. So now we tend to write statements. We write, scientists, talking about chemists and you yourself, when you are doing those experiments and do observations and you collect data and, you really define your problem. This is the problem I want to solve. When you reach EV level 300, yeah, and then you are going to level 400, you do, project. You have to find a problem you are going to solve. You understand? And if there's a problem you're going to solve, the same thing that I'm teaching right now. You see, when you reach that level, you see that you have to, solve some problem. All right. And all these problems, like I said, you solve them. The world is full of problems, plenty of problems in the world. And now, if you solve this, you are able to go through this scientific method and you solve a problem, you yourself will be happy. And besides the happiness, the world will reward you. And what will be the reward? It's the money that you get. You become rich person. All these guys, Mark Zuckerberg, and this guy, Intel. Intel went to my school. The guy, the man Intel, may he so rest in peace, Grove. So he gave my school $30 million. $30 million. And then they called the City College of New York as Grove School of Engineering. Grove School of Engineering. You understand? He's the Intel man. You can find out. You go to the net and find out. So all these guys, now you are someplace. I'm not close to you, but I'm teaching you because I'm using his course in the laptop that I'm using to teach you. Isn't it beautiful? Wherever you are, you can see my picture. I can see you, and you can talk to me. I can listen to you, and you can also hear me when I'm talking. Wherever you are, you could be in UK or you could be in Togo or Benin. You can hear me. So and I pay for it. Like I told you yesterday, how much I pay for my modem. I pay for it. And now you see the money, where does it go? It goes to them. And then they are enjoying the money too, because they solve the world problem. So you too, as we are, as an engineering student, electrical electronic engineering student, you don't even necessarily have to even reach level 400 before you can even solve a problem. You can start to find a way to solve a problem. All right. For me to have solved a problem, you say, Dr. Ben Asante, you're saying that we should solve a problem. What problem have you solved? Yeah, me to have solved a problem. You can go to the net and find out about me. You can go to Google Scholar and find out about Dr. Ben Asante. my publications. I can use appetition, the one that people drink to boost to the sulfur, to take sulfur from crude oil and also to take salt from crude oil. I did that. A different other problems that I saw. You understand? Sulfur can cause, acid rain and destroy landforms. And it's a mandatory, it's a law that if you have a crude oil and you are using a fuel from these hydrocarbons, you have to take the sulfur from it. And I've done that. That's also my contribution to the world. I'm expecting you as as an engineering student, also to contribute something towards the world. You understand? And then I get paid for what I'm doing. You think I'm just talking here for nothing? They won't pay me. They pay me for talking to you because I also have a knowledge to, impart on you. All right. So wherever you find yourself, right now, as you are, engineering students, electrical electronics engineering students, about a problem that you can solve. All right. Think about it. And now, if you are able to solve this problem, the world will reward you. They will give you money. You won't go hungry and you'll be happy. All right. So all of this, when you've collected data, you made a law, and the law, then you make some mathematical statement. You write it down. We engineers we write things down. We calculate. We calculate do this calculation. That's why we have the law. For example, we have this idea gas law, PV equals to NRT. Anytime you do it, you see you have the results for it. And the PV equals to NRT works all the time, right? Talk about Charles law, Boy's law, and all those laws. They work all the time. Wherever you are, they work for you. All right. And what is a law? A law is a concise, experimentally validated statement that describes the consistent, predictable behavior of matter under specific condition. All right, that's law. All right. I'm not talking about the law that lawyers go to law court and say, "Oh, I put you my honor, your honor, I put you this, I put you." I'm talking about the scientific law. All right, it's a concise, experimentally validated statement that describes the
the
predictable behavior of matter
predictable
under specific condition, right? And then the hypothesis that I was talking about is it explains the facts summarized by the law. It explains facts summarized by the law. A hypothesis is a working model that is adjusted as new information about the phenomena is discovered, right? So we have the hypothesis, and then anytime you get new information, you modify it, new information, to modify, those hypotheses, right? And a theory is developed as hypothesis survives many experiments, right? Theory is developed as hypothesis survives many experiments and adjustments. And what is a theory? A theory, a structural logical explanation of a phenomenon. Structural logical explanation of a phenomenon, behavior, or a set of relationships designed to explain, predict, and understand empirical observation, experimental observation. All right. It is a unifying principle that explains a large body of observations and laws. A unifying principle that explains large body of observations and laws. Right? Theories are tested using carefully devised experiments that confirm or disprove their prediction. All right. A theory is very, very, very important, right? When it leads to predictions across a wide range of observations. All right. So this is your introduction to chemistry, all right, to chemistry. And these scientific laws and then this procedure that you have to follow, it cuts across all angles, all right? Whether you are doing electrical electronics engineering or you are doing any other kind of field, it cuts all across. You need to do observation and you need to, find a way to really, do data, do experiment and then collect, data through the experiment and then make laws and do the prediction and hypothesis and all of them. You understand? Cast all across all fields. You understand? All right. Cast across all fields. All right. So, do you have any question here that you don't understand anything? Are you okay here? Are you okay? All right. So if you're okay here, then I will unshare this slide. All right. I'll stop sharing this slide and then I'll show you different other slide. Okay. Are you okay with that? Students, are you okay with that?
Yes, sir.
Yes, sir.
Very Oh, good. Patrick. Okay, fine. Iman, very good. All right. Kingsley, are you there? That's right.
Yes, please.
Very good. Very good. I want to know whether, like I
Hello, sir.
said, yes. Kingsley, do you want to talk to me?
Oh, no, I was responding.
Oh, okay. That's fine. That's fine. Sometimes I'll call you or I'll call somebody to see whether my network has not gone off because I can be talking and talking and maybe you may not be hearing me. All right. So that's why I called you. All right. So let me stop sharing this slides and I'll share another one. Okay. Yeah, gentlemen, are you there?
Yes, sir.
Good, good. Let's continue our studies of our general chemistry. All right. Yeah. Let's see. So we are going to study the subatomic particles. We talk about molecules, ions, and um these guys, Dalton's atomic theory, and this guy J.J. Thomson, he did some experiment with force. We talk about Bohr's model of the atom. All right, and then I think we'll be exhausting the time, and then we can close for the to go and spend our weekends. All right, enjoy the rest of our weekends. All right. We'll talk about it. The matter. Matter is anything that has mass and occupies space. Right? Matter. Right? It's anything that has mass and occupies space. right? We defined it, yesterday, right? That your book that you are holding, or your laptop, or your pen, they all matter. They have mass, and they are occupying space, right? This thing, the food that you eat is a matter. The dirt on the ground is matter. But sometimes there are some certain things that are difficult to identify as matter. Let me ask you guys this: is air a matter or not? Is air matter?
Yes, air is matter.
Why is it that it's matter, so that?
Yes,
Okay,
sir, because
air is a mixture of gas.
Oh, okay. Okay. No, you're right. It's true. It's a mixture of gases, and gases are matter. So it's a matter. And it's a matter. Very good, Sally. You said that. Hmm. All right. So matter, as you see here, right? We classify them, right? So here on the screen that you see is a classification of matter, right? Matter, we break them down into elements and compounds. Element and compound, right? And then the element, we can have one substance, right? One substance out of it. And a compound, we have more than one substance, more than one substance. And then a compound too, you can break it down. There are more than one substance. We can have heterogeneous mixtures, and then we can have homogeneous mixtures. We'll go over them. We'll go over them one by. So this is a flow sheet of matter that we can use to describe element, compound, element, one substance, compound, more than one substance, more if it's more than one substance, then we have mixtures, which are homogeneous mixtures, and then we can have mixtures which are what? Heterogeneous. Homo means same, hetero means different, right? So we'll go over them, then you see what they all mean. Okay. We already said that air, like how Sadat told us, he said air is a matter, and it's true, air is a matter, right? Things that are not make up, that are not matter, are your ideas, your emotions, and your hopes. They are not matter. They are not matter. But air is a matter. So now let me ask you this: which one of the following is not a matter?
Love. Love.
But are you sure love is not matter?
Yeah, it's not.
But love doesn't
it
occupy
it it
your
it,
mind.
it occupies your heart.
Love, I thought love was matter because it can occupy your mind and your heart. You can't even sleep when you met your first love. Eh? It's not matter. Okay. Every day you can occupy your mind. You cannot really quantify it. You cannot, it doesn't occupy there by, it doesn't have mass. So you cannot say it's a matter. Okay, so love is not matter. Rice and tree, they are matter. Love is not matter. All right. Love is not matter. Right. So there are two basic ways to describe matter. Right. Two basic ways to describe matter. Yeah. Because matter has properties. And those properties are the chemical properties and physical properties. Physical properties, chemical properties. And what are the physical properties and which are the chemical properties? We'll go over them. All right. And see that physical properties are characteristics that describe matter as it is, as it exists. They are characteristics that describe matter as it exists. Example of physical properties of matter are the shape of something, the color of something, the size of something, and the temperature of something. All right. They describe them as they are. Those are the physical properties of matter. So an important physical property of matter are the phase, right? Are the phases of matter, phases of matter, or the state of matter. And we have these three fundamental phases of matter, which we say solid, liquid, and gas, right? Solid, liquid, and gas. And this phase of matter depends on, the behavior. It's all about the temperature of that matter, and then the behavior of that of the atoms and molecules of that matter. All right. So they exist by how their particles arrange and behave. There are particles, which is the molecules and atoms, the ions, the way they behave, right? Solid, liquid, and gas. Then we have another state of matter too. We call it plasma state. Plasma. Plasma state is a high energy state of matter with charged particles. High energy state of matter with charged particles, such as ions and electrons that exist at extremely high temperature. They exist at an extremely high temperature. All right. So those are the fundamental ones are the solid, liquid, gas, the state of matter, which are the physical properties of matter, and also the plasma state, which exists at an extremely high temperature. All right. And then now we come down to the chemical properties of matter. Chemical properties are characteristics of matter that describe how matter changes form in the presence of other matter. How matter changes form in the presence of other matter. So burning is a chemical property, for example. So now let's find out these changes. Right? So those we can have physical change, and we can have a chemical change. All right. Chemical change goes down all the way down to the how the atoms and then the electrons, the bonding and this and that they behave. All right. So now here, right, we have three changes that are going on here on this slide here. We have water in the air that turns into snow, right? In the air. Ghana, there's no snow though, but if you go to outside where there snows, even when we were kids, there used to be snow. I remember when I was a child, there used to rain and then the snow will be coming from the sky. I don't know whether you guys have seen that before. No, has anyone seen the snow coming down from the sky, before in Ghana? Not abroad, in Ghana. Have you seen that before?
Sir, please,
So,
is it the ice block?
ice, yeah, it's ice block.
Yes, ice block. Ice block.
Yes.
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 Yes. I've seen that before. We used to pick them and eat them when we were kids. If you're a child, don't give a damn about whatever goes into your stomach. As long as you think it's nice, then you are eating them. They were so nice. But nowadays around here, I don't see that kind of ice blocks coming out from the sky though. I don't know, maybe. Where did you guys see that? Where did you guys see that?
So during heavy rainfall.
Heavy rainfall, right? Engineer, where? Which part? Which part have you seen this?
That's what some in Sunyani.
Sunyani. Oh, I see. Because I remember years ago when I was in Koko, it used to rain. When it used heavily, we used to pick ice block from the ground. But now it's been a while that I saw some around here in Accra or I don't know.
Yes, me also saw it
Well, I can see your this thing is breaking up.
Nkoko. I used to see that in Nkoko. I used to see, like as I was kid, like from Nkoko. That's where I used to see it.
Oh, okay. Are you from Koko?
Yes, from New Abrim.
Oh, New Abrim. Oh, I see. For me, I'm a woman, so I'm a woman, so I have a house out in Koko.
That's great. That's great.
Oh yeah. We used to see that. So if you are, for example, right, when ice is in the water in the air, it has turned to snow. Or if you go to your barber shop and you cut your hair. Yeah. Or you have a bread dough. you bake bread
you bake bread
in an oven.
in
So which one of them is a physical change? Which one of them is a chemical change? If you know, you can just omit yourself and say, or this is what we can do. Just write it somewhere. Number 1, physical change. Number 2, chemical change. Number 3, physical change. Number 1, chemical change. And then write it down. So we see that
So
whether we are
please, I think the hair will be chemical change.
okay. Somebody say the hair will be chemical change. Okay, write it down. What about the water in the air that turns into snow?
The first one is a chemical change.
Which one?
Water into snow. I think.
Water in the air that turns into snow.
Yeah.
It's a chemical change. Okay, what about the bread?
Okay.
That becomes, you put some bread dough in the oven and then you bake it. What about that?
Mm.
Alex, you want to say something?
No, sir.
Who can help Alex? Bread dough becomes fresh bread in an oven.
Hello, sir.
Yeah, go ahead, Patrick.
Okay, so for me, the first one is a physical change.
How about the second one?
The second one, I can't really tell because I don't have any explanation to back it.
To back it.
But I'll say a chemical.
Okay, he says a chemical. Here someone also says chemical. How about the third?
And the third one is a chemical change.
Chemical change. Okay. Now let's see the answer. We are learning. Let's see the answer. Because the water is going from a gas phase to a solid phase, this is a physical change. Remember the physical, water, right? When water changes from, from liquid to become a gas, become a solid. You can just go back and forth. So it's a physical change. You haven't really changed, anything. It's just physically you see this water, physically you see this ice, physically you see this gas. All right. So this physical change. And then if you have a hair, you go to the barber shop and you just cut your hair. It's a physical change. All right. And also the third one, because of the oven's temperature, chemical change are occurring in the bread dough to make it fresh bread. So it's because the temperature has changed, has changed it. You see that the dough has become something different. All right. So these are chemical changes. So the cooking, in fact, there are a lot of cookings are chemical changes. All right. So chemistry is like, also when you want to see what is going on, you go to the kitchen, you see that, oh, okay, I'm putting this together, putting that together to form different things. You take tomatoes, those who know how to cook, I know how to cook. Take tomatoes, you take onion, you take, oil, all right, and you take pepper, you grind them, you put them together. You are doing chemistry there, all right. You are changing all those ingredients to give you a stew, or if you want to make soup, whatever, and then you make it, all right. So a lot of cookies are chemical change. So the bread dough, become a fresh bread, it's a chemical change, all right. So let's talk about a substance, right? Let's talk about a substance. A sample of matter that has the same physical and chemical properties throughout is called a substance. Again, a sample of matter that has the same physical and chemical properties throughout, physical and chemical properties throughout, it's called a substance. So it is a form of matter that has a fixed composition and distinct properties. Fixed composition and distinct properties. A sample of matter that has the same physical and chemical properties throughout is called a substance. And it's a form of matter that has a fixed composition and distinct properties. Their composition are fixed. It doesn't change. All right. If it has two, for example, you say, okay, water is a substance. Okay. And now if water is a substance, does it change? Is it H2O? The composition, it has two hydrogens atom and one oxygen atom. All right. All over, whether it's an ice, whether it's a gas, or whether it's this, water, it's just two hydrogen atoms and one oxygen atom. It's the same throughout. If you take water, throughout wherever corner you take water from, it's in a bowl. You take it from the under the bowl or take it on from the top of the bowl. This composition throughout, right? The properties of water the same throughout, all the time. You say it's a substance, right? Substance, all right. So now, sometimes the phrase substance, we don't use, say, pure substance. Sometimes we just take away the pure and it says a substance. So whether it's a pure substance or substance is the same thing. Wherever you go and you are going to do exams and they define it for you and they say, okay, why is a pure substance? And the definition has the matter is a physical, matter that has the same physical and chemical properties throughout. And it's the same thing that when they say it's a pure substance or a substance, all right? So the same thing, all right? So now let's talk about two different types of substances. We have the elements and compound. Elements and compound. The one that we defined it from the beginning on the flow chart, elements and compound. So now what is the definition of element? An element is the simplest type of chemical substance. Simplest type of chemical substance. It cannot be broken down into simpler chemical substances by ordinary chemical means. You cannot break it down into simpler chemical substance by ordinary chemical means, right? You cannot decompose it into simpler substances by chemical reaction, but you can convert it by using nuclear reaction. The elements are the building blocks of which all compounds are composed. Elements, are the building blocks for all chemical compounds. If you talk about chemical compounds, then you take this element, take the element, put them together, this element, the element, put them together, and then you get compounds. All right, you get different compounds. All right. Some text defines that we have 150 elements. Yesterday we saw 118 elements. Some texts, are coming up with different amount, but then it doesn't matter. What we know is we have plenty elements, about 115, 118 types of elements, which 80 of them are stable. 80 of them are stable, right? And some of them, the rest of them are radioactive, right? When we say radioactive, they decay, right? They break up, all right? They break up. Raymond, are you talking to me?
No, sir.
Oh, okay. They break up. And those radioactive elements, they are very dangerous, They are very dangerous. They can give cancer. Those radioactive elements like uranium and all those radioactive, they give cancer. So you need to be careful. If you sleep on the bare ground, is dangerous. I see some people, they just sleep on the bare ground. Be careful. Uranium can enter into your body and then you can get cancer. All right. And cancer, that deadly, disease. All right. So you have to be very careful. Those are, the radioactive elements are the ones that they use to make bombs. And those are, bombs. So the rest of them, 80 are stable. The rest of them are, the radioactive elements. So each element has its own unique set of physical and chemical properties. Each element has its own physical and chemical properties. Like I said before, right? When you take the gold, right, and you take maybe carbon, you take maybe iron, you take silver, you take manganese, you take bauxite, you take all these elements that has God gave it to us, naturally. You understand? You see that they have different physical and chemical properties. Physical and chemical properties. All right. And then a compound is a combination. You take this element, take the element, put them together, you form a compound. There are plenty compounds. And those compounds, right? How they use this is, if I take, for example, this element gold, and I take maybe silver, I form an alloy, right? Their properties is different from when I form that ion, that compound, that alloy, right? Their properties will be different from the properties of gold itself and the properties of silver itself. They will have different form of property, both physical and chemical properties. Right? Even gold like this, the pure one. When you go to those places whereby they drink gold and then they manufacture gold, gold itself is different. But then they can form alloy, with different kind of copper or whatever, and then they will sell it in the form of jewelry to us. All right. Yeah, it's different alloys, different kind of compounds, different kind of compounds. All right. And these compounds, right, are very like about more than 50 million compounds we can form in the world.
Question now maybe Sam. Mean to me, say also nim say imagine na kasa.
Patrick,
Now
your this thing is on. So if you want to talk on the side, just mute yourself. All right.
I'm sorry. Thank
Oh,
you. I'm
that's
sorry.
okay. Sometimes we can talk and then you forget that you have not muted yourself. Don't worry. But okay, examples of compounds include water, penicillin, sodium chloride, other stuff. Right? Plenty of compounds, but more than 50 million. But compounds can be broken down into simpler substances by chemical reaction. Compounds can be broken down into simpler substances by chemical reactions. All right. So physical combination of more than one substance are called mixtures. Right? Physical combinations of more than one substances are called mixtures. Physical combination of more than one substances are called mixtures. And like I said, we have two types of mixtures: heterogeneous mixture and homogeneous mixture. Heterogeneous mixture is a mixture composed of two or more substances, and a homogeneous mixture is a combination of two or more substances that is so intimately mixed together that behave as a single substances. So another name that we sometimes give to homogeneous mixtures, right, are solution. So when they say, "Oh, we have a solution," this is a solution. That means it's a homogeneous mixture. All right. For the heterogeneous mixtures, you can see that. Oh, okay, they are there. You understand that you see different type of the elements that form that mixture. You can see them sometimes with your naked eye. That okay, this is this and this is that. Right. So now let me ask you this, my friends. Soda water, right? Soda water is carbon dioxide dissolved in water. Right? It serves as a buffer. It helps you, to regulate your pH level in your system. All right. So in this case, soda water is a combination of carbon dioxide that is dissolved in water and a mixture of iron, metal fillings, and sulfur powder, which is both iron and sulfur elements. All right. So which one of them is a homogeneous mixture and which one of them is a heterogeneous mixture? Or which one is them? It's a question. All right, students, let's get to work and answer these ones. It doesn't matter whether you get it wrong or you get it right. All right, we are still learning. We are in the learning atmosphere. I keep saying this because if you don't say it and you know it, maybe you know it. You say, "Oh, I should have said it." So please, which one is heterogeneous mixture? if all of them are heterogeneous mixture, or if all of them are homogeneous mixture. Let's find out. All right. Who goes first? Who will go first?
Sir,
Yes, Ima.
yes, sir. Sir, I think the soda water is homogeneous mixture, and then a mixture of iron, metal filings, and the sulfur powder is heterogeneous. My
Okay.
opinion.
Well done, Ima. Well done. Is there any other, differing opinion about what Ima has said?
No, I support it.
Support it. Let's support Ima. Who else?
Okay,
Who else?
so
Yes,
about
Ernest.
the soda water, it is homogeneous when closed or when sealed. And that's
Okay.
what I'll add to what he said.
Oh, okay.
The carbon dioxide will be trapped inside.
Oh, okay. Okay. What about anybody else also? Contribution. Ernest has contributed something. All right. When we come to clarity, we need to contribute to. Right? You are in society, wherever you go, in the meetings, you go to some place, you need to contribute. You contribute something. They know you are also there. I say you go and sit down there, and then you go quietly. Nobody will know you are there in society. These politicians, why they, are they better than you? They are not better than you, my brother. Alex, Ernest, they are not better than you. But then when they go, Mr. Speaker, Mr. Speaker, Mr. Speaker, and they are taking all our money, they're enjoying themselves with me and you, our money. They go and stand there, Mr. Speaker. All what they do is to talk. So we go to the place, we talk. Me, I talk. I like to talk. I like to talk. All right. And some of them GC2, your fellow classmate, that person was a senior. At Takrade campus, the guy was a level 200 guy. He was an MP. He was a member of parliament, taking all plenty money. When they finish they get this, they finish their term, that 4 years. When they go there, some of them don't even talk. They don't even talk. After that 4 years, they say ex gratia. After taking all this money from me and you, our taxes, then they say ex gratia. Then they give them plenty money for them to go and chop. So let's also be articulate, all right? Contribute something. Right, all of you, you are right. Whatever you said is right. So the water, carbon dioxide dissolved in water. Let's see the example. Because carbon dioxide dissolved in water, we can infer from the behavior of salt crystal dissolved in water that carbon dioxide dissolved in water is also a homogeneous mixture. Right? So assuming that the iron and sulfur are simply mixed together, it should be easy to see that what is iron and what is sulfur. So it is a heterogeneous mixture. So the answers that you guys gave, you are all right. All right, you are all right. And even if you were not sure your answer, and that's the reason why you didn't say anything, this is the answer. Please go over them. All right. So mixtures do not always consist of specific proportion of substances. And mixtures can be separated into components by physical method. Mixtures, you just can't separate them by physical method. All right. Now, this is your homework. The homework is also on your model book. All right. So I expect you to do the homework and do the submission. Okay. Do the submission. It's more homework for you. Right. Look through your model book. They are all there. All right. Now they are all there. So we're done with this one. I'm going to show you one more slide. All right. And when I finish, all right, I send the slides to the platform, and also we can close so that we can go and spend our weekend. All right. Are you guys okay?
Yes, please.
Oh, great. Yeah, we are going to go in depth, all right, to talk about those atoms and molecules, and then talk about ions and all those other stuff. All right, we'll go in depth about the subatomic particles, right? Subatomic particles. All right. We say the smallest piece of an element, right, that maintains the identity of that element is called an atom. You keep defining atom. Why? And doc, you always keep talking about atom, atom, atom. Eh? They're talking about atom. In the environmental studies class, you say atom. Where do you chemistry to you say atom? And then first like we take atom. Because you see, they are very, very important. You see, if the fundamentals are broken down, everything is broken down. Everything is broken down. So in Ghana, like this is our country like this. If our fundamentals, because we don't get things right in this country, our fundamentals are broken down. That's the reason our country is like this. Dust all over the place. People are building kiosks all over the place. Our roads are, potholes and our fundamentals. My students, my friends, you check. Our fundamentals are broken down. I know some of you have traveled abroad. And when you go to the abroad, is that how their rules are? Go to the fairs where the white man's country. Is that how their rules are? Somebody say that, oh, the white man country, they are developed and this and that. Travel to South Africa, where the white people stay, and go and see. Go to Johannesburg, go to all those places and see how they have developed. It's not in America. I mean, not in Africa. That's African countries. They are doing very, very well. Botswana, those places are doing well. I don't know in Africa. Why is it that Ghana, our countries, is so, dirt and, dusty roads and, potholes and even where I live right now, my students, there's no any potable pipe-borne water in my area, just behind the Western Mall. But when you come down closer, there's pipe there, going there to where the Sunda and then the Sunda, they have their factories and all those places, where they have Creosote. Western Mall, they have water there. But when you come up here, no water. Why? The fundamentals are broken down. So I'm talking about atoms, atom. Because it's a fundamental. It's just the basic thing in this thing, in all matter. That's why we talk. But if you are able to, engineer the atom, you engineer the atom well, then you are getting something better. So if we Ghanaians, our fundamentals are really put into good perspective, you see, our country will be, will progress. The mentality that our parents didn't, impart in us, right? Or the mentality that our parents give to us is why it's carrying me and you. You understand? So we try to talk about atom all the time. Atom all the time. Because it's what you manipulate. It's what the scientists manipulate to give us different things. All right. So you see the smallest piece of an element that maintains the identity of the element. It's called atom. Individual atoms are extremely small, very, very small. And it will take about 50 million atoms in a row to make a line that is 1 centimeter long. All right? To make 1 centimeter long. Atoms are so small that it's difficult to believe that all matter is made up from them. Right? And it's true. The smallest part of that matter is what we call the atom. All right. And there was this guy called John Dalton. He was an English scientist in 1808. He formulated fundamental rule in chemistry. He formalized this atomic theory, modern atomic theory. Right? He formulated John Dalton. He's an English, this British guy. Those guys, the guys who came to colonize us, our great grandfathers, they colonized us. Right? They made us. We had drinks here in Ghana, but they brought drinks to our forefathers. And they took some of us, our slaves, and took them to this place to go and work in the Western world. Go and work in the Western world. John Dalton, right, was from English. In 1808 is when he formulated this atomic theory. And this is what John Dalton says. He says that All matter is composed of extremely small, indivisible particles called atoms. That is one of his things that he said. And he's saying that an atom is the smallest unit of an element that can enter into chemical combination. Atom is the smallest unit of an element that can enter into chemical combination. And John Dalton is saying that the atoms of the same element are identical in size, in mass, and in chemical properties. Atoms of the same element are identical in size, in mass, and chemical properties. And John Dalton is also saying that atoms of one element are different from atoms of any other element. And then Mr. Dalton keeps saying that compounds are formed when atoms of two or more elements combine. And then atoms combine in a small whole number ratio. They combine in a small whole number ratio. And he's saying that for a given compound, the ratio of atoms of one element that combine per atom of other element is fixed. When you are talking about it's fixed, it doesn't change, right? And John Dalton is saying that the smallest particle that has the properties of the compound is called a molecule. The smallest particle that has the properties of the compound is called a molecule. And Mr. Dalton said that atoms are the smallest unit of chemical chain, the smallest unit of chemical chain. And he's saying that chemical reactions involve the combination, separation, or rearrangement of atoms. Chemical reaction that chemical reaction involves combination of atoms, separation of atoms, or rearrangement of atoms. You cannot destroy atoms or create atoms in chemical process. When we are doing this chemical reactions, chemical process, you cannot destroy atom or you cannot create atom. You can combine atoms, you can separate atoms, or can arrange atoms, but you cannot destroy atoms or create atoms. And this is an atom, right? This is an atom. In the middle here, like I said yesterday, the middle here we have the nucleus, right? That's the core nucleus. Then we have the protons inside the nucleus, and then we have the neutrons also inside the nucleus. So inside here, the nucleus is reserved for protons and neutrons, Pn or Np. Neutrons and protons, they are in the nucleus. And then around it, we have the electrons. They are running around in their orbitals around the nucleus, right? That's the electrons. I'll talk about silicon, right? Silicon atom, right? The mass of that silicon atom is 28.085, right? And it has an electron configuration of 284. We'll do that electron configuration and you understand it. Some of you may understand it because some of you may have done chemistry before. And then if you have not done chemistry before, don't worry. When we go through it, you will understand it, all right? How the electron configuration is, all right? So that is the mass of the silicon atom. When we talk about the mass of it, we're talking about the mass of the protons and the mass of the electrons. I mean, mass of the protons and mass of the neutrons put together. That will be the mass of the atom. Okay. This is silicon. The taking silicon element. This is how it looks. Silicon is a chemical element with a symbol Si and atomic number 14. Its atomic number is 14. Right? It has this property. It's a hard, brittle, crystalline solid with blue-gray metallic luster. Blue-gray metallic luster. It is a tetravalent metalloid and semiconductor. All right. tetravalent metal and semiconductor. It's a member of 14 in the periodic table. It has carbon above it, and the germanium, tin, and lead are below it. Relatively, it's unreactive, right? And see, I just selected silicon for you because silicon is very, very important. Important in your electrical electronics engineering work, right? We can use to make alloy, right? We combine it with the other kind of elements to form different things, right? Combine silicon with other elements to form different things. And in electronics, right? One of the most important properties of silicon is that it works as a semiconductor, right? Works as a semiconductor. And even the solar panels that we are using, we're trying to move away from the, those hydrocarbons to use renewable energy. So we are using solar panels, right? So these solar panels, we use silicon to make them. We use silicon to make them, right? And when you come back to our computer chips, our transistors, we use silicon, right? So that's the reason why silicon, I selected silicon for us to talk about, which is very, very important, right? And this is a beryllium, right? The beryllium atom. It has its nucleus, has its protons, and then protons and neutrons, they are in the nucleus, and then we have the electrons in their orbitals. And here we have the electron configuration that I was talking to you about, right? You see in a minute. See, we have 1, 2, 3, 4. I'm talking about the circles. See the circles here? We have circle 1, which is named as K, circle 2, which is named as L, circle 3, which is named as M, and then circle 4, which is named as N. All right. And those are the shells. We call them shells. Right? We call them shells. Shells. All right. So N is N shell, M shell, L shell, K shell, right? And inside the atom is a positively charged nucleus. Why? Because proton is positively charged. Proton is positive charge. Electrons, negative charge. Neutrons, no charge. No charge. Protons, positive charge. All right. So we have K, L, M, N. KLM. OP, right? I didn't show the OP here. KLM. All right. So now, those shells that you see them, let me go back there to show you. These shells that you see them, right? They also have subshells. Subshells. Right? Like GC2, and then the whole school is a GC2. We have those who are doing electrical electronics engineering. We have those who are doing those students who are doing computer engineering, or even let's take the faculty of engineering itself. Faculty of engineering is the shell. We have electrical electronics engineering students. We have computer engineering students. We have telecom engineering students. All right. So that's what it is. So these shells, K, L, M, N, they also have some shells in them. We call them subshells. Subshells. So the K, for K, it has only one subshell, which is S. All right. K has only one subshell, which is S. And then the maximum electrons in that subshell is 2. When I finish explaining this, we'll close. Okay. That will be 1 o'clock. I'll close at 1. All right. K has one subshell, which is S. Its maximum electrons in that subshell is 2. The maximum electrons in that subshell is 2. Now then we have the L. L, right? The L shell has 2 subshells, the S and P. S and P, right? 2 subshells, S and P. And then the S also, the maximum number of electrons that S can accommodate are 2. The maximum 2 electrons. The S, so no matter where you see that S, the maximum number of electrons that S can contain is 2. And then the P it can contain only 6. The maximum number of electrons that it can contain is 6. So then the 2 plus 6 will give you 4. Telling us, give you 8. Telling us that the maximum number of electrons that L shell can take is 8. Right? L. 2 plus 6 is 8. So now when we go to the M, right? The M can contain S, P, and D. S, P, D. The M. S, P, D. All right. So the maximum number of electrons that S can contain is 2. The maximum number of electrons that P can contain is 6. And the maximum number of electrons that the D can contain, the D subshell, is what? Is 10. So when you put them all together, you add them all together, so we have 18. So 18 is the maximum number of electrons that M shell can have, right? And inside the M is the SPD. Right? Then you come to N, SPDF, right? The maximum number of shells that the N can contain is 32. How did it come out? The breakdown is this. The S contains 2, the P contains 6, the D contains 10, and then F can contain 14. So that's how it goes, all right? Here you see them, they are so much bunched up together. It's the shells and then the maximum number of electrons that they are there, and then the different of them, right? The S, the P, the D, and then the F, all right? So that's how it contains. And now you see this thing that I'm showing here, right? The electron configuration thing. Now we have 1s2, 2s2, 3s2, 4s2, 5s2, 6s2, 7s2. Then you drop down 2p6, 3p6, 4p6, 5p6, 6p6, 7p6. Then you drop down one, 3d10, 4d10, 5d10, 6d10, 7d10. Then you drop down one, 4f14, 5f14, 6f14, 7f14. See them. This is very important. I want you guys to learn how to put them like this, right? And learn it's important, not too difficult, right? And learn how to do it because this is what we are going to use to do electron configurations, all right? So the KLMNO, P, Q, that's how they are, all right? That's how they are. So these are the laws. The law of definite proportion, right? And the law of definite proportion is telling us that all purified samples of a compound contain its constituent elements on the same proportion by mass. Anyway, before I talk to you about these laws, all right? Is there any question on whatever we're doing, here? Any question here?
Hello, sir. Hello, sir. Hello, sir.
Go ahead, Kingsley. Go ahead, contribute.
Sir, please, I want to find out how you came out with the electron configuration.
Okay, Kingsley want to know how I came up with this electron configuration, how it is, all right? You see, the way it is, right? If you want to configure, you want to know how the electrons, right? The electrons are around the nucleus, how they are being positioned around the nucleus. This is the method that you use. And this is a standard method that you'll learn to use to do that work. Do you get what I'm saying? I did not formulate it, right? It was formulated some time ago, you understand? But you learn this so that when you are doing the configuration, you are trying to, when I say configuration, I mean how you are going to position how the electrons are positioned around the nucleus, then you use this method. It helps a lot. All right. I didn't come up with this by myself. I learned it. Do you understand? I learned it. And then the way I learned it and it helped me, that's why I'm also showing you how to use this method to do the configuration, to see how the electrons are really positioned around the nucleus. And this is the thing. We use this so that we can know how much the electrons who are, outside, how many of the electrons who are outside, the type of bonding that they will bond, whether it will be, covalent bond or they can be ionic bond. You see, so we learn this, it has a purpose. You understand? So you learn the way they are, and we can use this to do our electron configuration. Kissy, am I okay?
Yes, sir. Yes, sir.
Very good. Very good. All right. So now let's move on. Right. So now let's talk about the laws. The law of definite proportion. The law of definite proportion is saying that all purified samples of a compound contain its constituent elements on the same proportion by mass. Right. For example, the compound of carbon monoxide, no matter where you take the carbon monoxide from, whether you take it from Accra, take it from Hope, whether I take it from Abidjan, whether I take it from US, it contains 43% of carbon and 57% of oxygen. But whatever the sources, that's the law of definite proportion, right? And no matter what it is, the oxygen atom mass is about 1.33 times greater than carbon atoms. That's the law of definite proportion. All right. And the law of multiple proportion say that when two elements form more than one compound, the masses of the elements in the compound are related by small whole number ratio. They are related by small whole number ratio. For example, let me use carbon and oxygen, for example. Carbon and oxygen can form carbon monoxide, isn't it? And then carbon and oxygen can form carbon dioxide. All right. It can form that, all right? But then the oxygen that is in there, and then in the carbon monoxide, and the oxygen in the carbon dioxide, they are related in whole numbers, all right? In carbon monoxide, oxygen is one, right? One integer. The carbon dioxide, oxygen is two atoms of oxygen. Carbon monoxide, one atom of oxygen. So they are related by whole numbers. They are not related by fractions. And so that's the law of multiple proportion. I'll close from here, all right? And then I'll push the notes on this for you, all right? We'll talk about all these things next time when we meet in class. But I want you to go over them so that when they come in class, and our work will be easy for us, students. Any other question before we close, based on whatever you have learned so far? All right. If there's no any question, then we can close. Yes, engineer.
Sir, please. So the K, N, M, and all those things, did they have a? Do they stand for something? And then they have
Yes,
a.
it's one of your work. I want you guys to go and find out what they stand for.
Okay, sir.
Right. Their principal energy level, though. Their principal
Okay.
energy, quantum energy level. We'll talk about them. But before then, I want you to go and find out what is K for, what is M for, what is L for, what is N for,
Okay.
what is
Okay.
OK. All right. Go and make that, that search. All right.
Okay.
That will increase your knowledge more and more. All right. And God willing, we'll meet again. Is it next week? Friday? Friday, right? Is it Friday?
Friday next week.
Next week, Friday.
Yes, sir. Yes, sir. Environmental studies.
All right. But you can, WhatsApp me in case of anything. Just WhatsApp me.
Okay.
All right. I wish you
Okay.
guys nice weekend. All right. God willing, next week.
Okay.
Sure. Bye-bye for now.
Bye.
sir. Guys,
Yeah, we are here.
I beg the learning model, is it the same as the slides or
The LMS.
like no, the course model is not the lecturer was talking about some course model.
I beg your voice is very foul.
I said yes.
Can you loud it more? Can you
What he's trying to say is
emphasize?
this. Basically, he's trying to ask whether the model book, right? The model book that you guys have. Yeah, I prepared a slide from the model book.
Okay.
Yeah. So when you read, you go through the slides, right? And you read the book, it gives you more understanding. But I prepared a slide from the model book. I'm the one who prepared them. I'm the one who prepared the model book. You understand?
Okay, sir. Yes, sir.
So it's all together. Because see, I can't use the model book here because otherwise it will be plenty on this. But I summarized the model book on this slides. Do you
Okay, sir.
understand?
Yes,
So
sir.
it's almost the same thing.
Okay, sir.
It's the same thing. That's what I'm
Thank
saying. But it's a summary of the model book. Okay.
thank you, sir.
You are welcome, Alex. Anyway, I'll see you guys later. Sure.
Hello, class. So our next class is the engineering technology. Please, can you hear me?
Yes, sir.
We
Yes,
Yeah,
sir.
can hear
Chris.
you.
Yeah, we can hear you, pa.
Okay, so our next class is engineering technology, and it starts from 1:45 to 3:45. 1:45 to 3:45.
Okay, you don't say we have about 40 minutes more.
Yeah, we have about 40 minutes.
Oh, okay.
This one, it was supposed to close 1:30, exactly 1:30, but I'm sure he has given us some time.
Charlie, but it's good. It's good the evening when because Charlie, chemistry the old bro, I say be winter more.
Charlie, don't you catch it up, catch it up.
Hey, because Charlie, me chemistry team me course kuna me pay science o.
Oh, but me sure say yeah, go anymore. Some courses we will be cutting off. I'm be
Oh
cutting
yeah,
off some
I
courses.
think say from me sure from level 200 they call the but good to say ebesua. I didn't know. I
What's
didn't the old Johnny
say?
free hun. I know so now eda we ni mo. The old Johnny no, I know eda we ni.
Na udwane akwa.
Okay. What we are learning right now, the elements and all those things, it is building our foundation on electrical currents, how current flow and all those things. So when we are going into it, we will learn why we have some semiconductors and conductors. So that is the beginning. So if we don't know this one, our knowledge in current and electricity will not be will not stand out. So I remember we did this in the technical school as electrical students and like this. So just that I'm this is the high level.
Master, this no be the high level. Vomit whatever you know.
Oh, this is the starting now. This is the starting now. We will learn the bond and that the cat iron and anion and all those things. So when we get into it, we see how the materials behave before we have conductors, before we have non-conduct the insulators and all those things. So this one will help us to understand. So when we get the concept from here and we reach that place, we'll be able to understand it very well.
So you are a good resource to us
Let's pray. Let's pray.
on this topic. So, guys, what do you think?
That be your Charlie.
You are a
Yes,
good resource to us. It doesn't mean we will not do anything. We will all try to do, but your understanding is somehow good. You already understand, so you need some small top ups and other things. So that is why we need to start the group learning
Oh yeah,
as soon
yeah.
as possible.
We have to start because we have majors in the room. So I think what the lecturer said, if we try to share ideas and then try to we will not be selfish. Everybody, if you know something, you come up, but then like we share idea, it will help us because the pressure is too much. So sometimes you have to take something small from people and gather it and to help you in the that you have to start a group learning.
So on this note, when are we starting our group learning, group studies?
And this one too, we are not plenty like that. We will say we share group A, group B, group C. Or what do you think?
But I think that one it depends. That one it depends, Charlie. Because I'm not sure they
It's
can.
Mr. Philip with us. Philip.
Yeah.
So with the group, how do we go about it? Let's all discuss because we don't have time. For us, we don't have time. So once we are in the weekend, let's do something, put things in place before we start the week.
Yeah. It's very important.
Hey, I don't know how you see us.
Mwamiana.
Serious students.
Charlie guy, what's that? Minemi huni say, ubiaba no abeshe ne slice no cool. And this is regular student obenya ho time no achire mu. Tano no uncle ready be pre-kra na obe pick 70% of class on. Atwe no oboso a na go movie con next slide. Oboso a na movie con next slide. Ti ya say juma na kase jina yen so.
Charlie, no busy. So me, after night come, I no sleep. I go there. If my time catch, no, I dey go back again. No rest.
So inti you wait mind say ebia during the weekend there, yeah, class because you started Friday in Umrea. Say you share your slides move to the next Saturday morning, then the lectures will start and everything. So can we do it during the weekdays? Monday, Tuesday, Wednesday, Thursday with the group studies. Hello.
Yes, we did.
Or
Yeah, Charlie, we do.
before break, then evening time we discuss. Evening
Okay.
time to people go day in hurry after the
Yeah,
last
Or
lecture.
maybe 9 o'clock day. At that time, everybody there in house.
But as we dey speak now, some people dey job side though.
Evening chair, they job say.
You know, be easy.
Then before pause the discussion and we discuss during the evening around 9.
Yeah.
Sure.
Sure.
All right,
Sure.
then Charlie, make we break up then everybody for stretching body
Okay.
then thing.
Okay.
Yeah.
All right.
Now
Okay.
I they take my lunch.
Hey Charlie, make one.
Okay.
All right.
Abu, how do you stop the web? How many months?
Which one?
Web. You guide the month to
Small. Like 3 months, I think. You will stop before so long.
almost 1 month.
No, not reach 1 month.
You know, 1 month. We'll sort of say next month. 2 weeks or something.
4 months.
Then people say they want cap, but I need to make them in the advice them to pay the tax. Well, you say you get money. You just have to do it one day. Run make it.
I'll put your like in for alarm.
And we say make money.
For alarm. Today, what to do?
Yeah, I say
If I make them go.
you did that.
This one will make IT. Then change.
You too. Yeah, go on. Then we do on go. Different man laugh. No go to smoke. No go do something. We'll make it change in his life. They will go to one. Maybe talk someone. You did that to you. I don't know why I couldn't say.
Bobo.
Man, we will see one time and then you talk and say.
Why you don't do so?
Man, they no good.
But that make it come back. You know good, but at least that
Better.
before you will come out, you know will come and tell me. But that 2 years, day here, no good.
No,
Any service.